Welcome to the Authority Podcast, Plumbing and Mechanical. When talking about the built environment, we would do well to remember, we shape our buildings, and afterwards, our buildings shape us. Therefore, on each episode, we'll discuss the latest trends from IAPMO in plumbing and mechanical safety, sustainability, and resiliency. Join me, your host, Christoph Lohr, and together we'll explore the ways we can make our buildings shape us for the better. Epic Cleantech is closing the loop on water, helping buildings recycle up to 95% of their wastewater right on site. Named a Time Magazine Best Invention of the Year, the Epic One Water system has set a new standard for water reuse in the built environment. Learn more at epiccleantech.com. Welcome back to the Authority Podcast, Plumbing and Mechanical. On this episode, we're going to talk about solving insufficient sewer capacity through water recycling standards and lessons from Vancouver, British Columbia. The city of Vancouver is consistently named among the world's most desirable places to live. The region is expected to add nearly 1 million more residents by 2050. Massive development leads to growing pains for any city, and for Vancouver, the dirty secret was insufficient sewer capacity. Chris Radziminski, building policy engineer for the city of Vancouver, British Columbia, shares how water reuse systems and correctly sizing systems helped mitigate the impact of stormwater on the city's combined sewer overflow infrastructure. Chris, welcome to the show. Excited to have you.
Thanks for inviting me.
Well, we sort of mentioned, about Vancouver's dirty little secret, and this was a term that we, not to be, not to try to paint a negative light. In fact, it was your colleague Philip White who, at the Emerging Water Technology Symposium in San Antonio, sort of talked about this. And so, can you tell our listeners a little bit about what Vancouver's, quote, dirty little secret is, based on what Phil said?
Sure. Yeah. Thanks, Christoph. So, dirty it is, little it is not, and secret it is not, since we're talking about it. But what my colleague was referring to was the combined sewer overflow issue in the city of Vancouver. So, like many North American cities, older cities, our infrastructure was developed with a combined sewer system. So, in a one-sentence summary, that means that all of the domestic sewage, all of the rainwater runoff, all of the industrial wastewater, all goes together into the same pipe to be delivered to the wastewater treatment system. That's the premise of that type of system. Unfortunately, in Vancouver, that infrastructure is very old. It's not been able to keep up with the construction of new houses and addition of new jobs in Vancouver. So the system periodically overflows. So what happens is that all of that water and that sewage doesn't necessarily make it to the water treatment plant or the wastewater treatment plant, especially on rainy days. So it will overflow into receiving waters, and then sometimes even in Vancouver, unfortunately, leave it back up onto streets or into private property. So it's quite an issue. To give an order of magnitude for it, in 2020, it was 10 billion gallons overflowed in the city of Vancouver. That's, for those familiar with the city, that's equivalent to 16 of our BC Place Stadium volumes. And maybe as a comparison, just south of us, of course, is Seattle, Washington, and King County. And in the same year, they had maybe 1% of that as in combined sewer overflow. So it's an enormous problem here in Vancouver that a lot of staff are working on. Wow.
Well, and I guess, when it came to that sewer system being compromised by stormwater, as you just described it, it was compromised by those heavy rainfall rates, those heavy rainfall days, in essence.
Yes, but it's also increasingly now smaller rainfall events are also leading to overflows in particular neighborhoods as well. Again, it's the legacy of an older system. It's extremely difficult to keep up with with development that's happening in Vancouver. This is underground infrastructure, so it's very disruptive, to be pulling out pipes, repaving, and those pipes have to be done all the way from where you're located all the way to the wastewater treatment plant. So it's not just a matter of upgrading on your street or your block necessarily. It can involve some massive upgrades.
Well, and then I guess in order to fix that problem, the city of Vancouver, one of the innovative approaches you guys took was about water reuse, and specifically a certain type of water reuse as it relates to stormwater, rainwater. And maybe you can tell our listeners a little bit about what you learned about existing water reuse installations and installation methods I think you touched on there's 3 categories as you were explaining to me before the podcast as we were preparing.
Yeah, so what you're getting at is that private properties have to do more to assist in this issue and to manage the rainwater where it falls. So one of the difficulties, of course, is typically when you're redeveloping the pervious area, so that's the area where the rainwater can naturally soak into the ground, typically shrinks. So that adds more complexity because now you have more rainwater that needs to go into a pipe. So with new developments in the city of Vancouver, they're required now to do more to manage that rainwater on their property. So to your question about the 3 categories, broadly speaking, you have really 3 opportunities as a private property owner on how you manage that rainwater that hits your site. Number 1 is you can put it into the ground. So, through landscaping, vegetation, etc. That can be limited, especially when you have 0 lot line developments. Here we have underground parking garages that can extend to the extent of the property line. So sometimes that's limited, or other complicating factors like groundwater, high groundwater tables, or pollution or contamination in the soils. The second is you can put it into the atmosphere. So again, if you have trees on your site, or some use green roofs, they also, of course, have their pluses and minuses, particularly in winter, where evapotranspiration rates are reduced. And then thirdly, it's reusing that water. So that's really the subject of our conversation today, Christoph, which the premise there is the rainwater falls, hold it on your site, so you're reducing those peak discharges, and then offset the potable water that would normally be used for, let's say, your toilets or your cooling tower, and use the rainwater that you've collected. So one of the benefits with something using it for like a cooling tower is now that water is actually evaporated off. You're not even putting it into the pipe in the first place, and you're not using potable water for it. So that's one of the tools that we're certainly looking at here in the city of Vancouver.
That makes a lot of sense. In essence, using that water reuse to minimize the impact on your stormwater systems, and that combined overflow situation. So you can you tell our listeners a little bit about what that process was like, about in terms of proposing new standards to try to fix that issue, and can you tell us about any how the stakeholders how they reacted, and if they were negatively reactive, or if they were receptive to these new standards that you were kind of working towards, and maybe touch on what those standards are.
Yeah, I'd love to use the past tense that it's fixed. It's not fixed. It's going to be it's a work in progress. So we're working on it. So I don't want to misguide your listeners into thinking that we've solved it in Vancouver. We certainly are working towards it, but have a long way to go. So in terms of proposing standards just generally for managing rainwater on site, when we laid out the case for the situation in Vancouver, the development community, consultants, engineers, contractors were very receptive to it. They understood what the issue was. These are not things that you can solve instantaneously, and they involve a lot of money. And so there was an understanding that, okay, private properties need to do more. We're not prescriptive in what approach you must take as a developer. We just give you a performance target. You have to manage this amount of rainwater. So if you choose to do a rainwater system, like where you're taking the rainwater and you're using it for non-potable applications, what we found was our current, we call it the building bylaw, it'd be equivalent to your codes in other jurisdictions, didn't really provide much guidance. There were maybe 5 or 6 sentences, very, very general. So we worked with consultants, the health authority, our colleagues, to develop something for consultants to understand, this is what's expected of your system. So we started with basic things like sizing the pipes, how you design your system, some of the expectations that are in that system. We don't say you have to use this particular type of disinfection, et cetera. We just say, at the end of your system, here are the expectations in terms of water quality. So that's what we've done. It's been received very well. We have some new systems that are coming online. We have some ranging from very small, one came online this year, which is just a small park with several toilets, to one massive development, probably one of North America's largest, which is multi-buildings, collecting all the rainwater from that site, also using groundwater, that's the nuisance groundwater from that site, using it for toilets, vehicle wash facility, cooling towers, some laundry machines, and some irrigation.
Fascinating. And from what we also talked about as we were kind of preparing. You also mentioned to me how to try to maybe offset some of the costs, it seemed like, of some additional systems. You looked at alternate sizing methods for the water system to kind of help maybe try to offset that a little bit. Can you touch our listeners on that? Because I think that was part of you really had some holistic thinking as you've kind of explained this to me.
Well, thank you, Christoph. And it was very well timed because we had learned about the IAPMO water demand calculator through, I can't remember which conference. And that was of particular interest to us, not only in terms of designing better systems. So instead of going back to the Hunter's curve and these ancient calculations where we no longer have toilets that flush those volumes of water, thinking in terms of material costs, and IAPMO has some fantastic materials about the savings that go with the smaller pipe sizes. Obviously of interest here in Vancouver, where affordability is also an issue. And then in terms of public health, so thinking about stagnant water and how do we minimize the amount of stagnant water sitting in a building. That's of interest in non-potable systems, Christoph, because as I mentioned, we don't prescribe that you have to have chlorination, for example, for your rainwater system. You may choose to, and some do, but typically people are using filtration and UV. And so with UV, you don't have that disinfectant residual in the pipes afterwards. So we don't want that water that's been treated now sitting in some purple pipes in the building for 3 days. So the smaller the pipes, the better to deliver that water to the user so it keeps moving.
Fascinating. So obviously you guys took a really big approach, a lot of new things, right? Water reuse requirements, new pipe sizing, how that all worked together, minimizing that impact. How did your jurisdiction have an adequately trained workforce to implement these new standards and ideas and solutions? And if not, how have you worked to try to overcome that barrier to date?
So the one-word answer to that will be a lot of education. That's 3 words, I guess. And that's really we're really thankful to IAPMO for your help. Christoph, you've been involved with some of the conversations we've had, even on a development scale, where the engineers are learning about this, and as engineers typically are a bit more conservative, and good for them, right? To make sure that they understand what they're doing here, and to understand, how the sizing works, how it was developed, how it will work for their building. To more broadly, through some of the materials that you publish online, through some of the seminars, Christoph, you held last year and the year before, those have been really helpful internally for inspectors and for the policy staff. Externally, for those who are now using it, as well for consultants and contractors, we've done a lot of seminars. We've done some lunch and learns directly with groups. And like anything else, there's going to be the early adopters and the people who are going to wait and see what happens. So while the water demand calculator is mandatory for non-potable systems, in the city of Vancouver, we've also introduced it as an option for potable water systems. So there's a time period now where people can choose which they'd like to use. If they'd like to use the traditional sizing methods or the water demand calculator method for potable systems. We see people already going down on the potable side for the water demand calculator. And I think industry is also going to learn as well, hey, this building was successful, their costs were reduced, even maybe the wall thicknesses were less, getting more valuable floor space. And I think in a way it's going to sell itself too. So people will learn when they understand what the benefits are too.
That makes sense. And so really, this is, for me being in Arizona, probably one of the most water-starved areas, and you're in Vancouver, probably one of the most water-rich areas, in terms of access to water. There's all kinds of water stress, and so let me ask you this kind of on our sort of, as we're wrapping things up here. How did your experience change the way you think about homes and buildings and how they're built and renovated? Also, I guess, and how that construction occurs to alleviate water stress. I mean, what has there been any changes in how you think about that now?
Definitely. So you've alluded to the difference between Arizona and where we are in British Columbia. So while our primary driver is trying to minimize what goes into the sewer system, there's definitely the interest in reducing the potable water use per capita. We have an extraordinary amount of drinking water we use per person per day here in Vancouver, and that really needs to be reduced. For a variety of reasons. And so what this has really helped us to think about, you used the word holistic earlier, is to think about pipe sizing on the potable side, which we've addressed as well, then the public health implications as well, like Legionella is this growing concern. And so we've worked with you and in terms of also developing water efficiency standards as well within our code. And so we go from everything from the traditional things people think about right to mechanical systems people might not think about, like once-through cooling systems, and then appliances. So we really have tried to deal with things holistically to try to reduce, let's say, the water footprint within new developments, so that we're reducing the amount of drinking water that's being required in those new developments, and also the amount of sewage that's being generated.
So that's interesting. So it really seems like there's a plumbing-centric focus as part of trying to reduce your water footprint, as opposed to just on the distribution side.
Yeah, I'd say plumbing and public health, they really go hand in hand, because plumbing is public health, right? And so, I mean, one of the famous expressions, or maybe not so famous, is that, if you were going to ask somebody, what's more important to you, the indoor plumbing revolution or, social media? I mean, toilets are more important than Twitter, right? And we forget how important and what a difference it's made to public health. And with the emergence of opportunistic premise plumbing pathogens like Legionella, we also have to be cognizant about how we're designing buildings and also operating them. And so something like pipe sizing is one of those things where, you're baking it into the building. So let's get it right from the start. Makes sense.
Well, really has been awesome having you on the show, Chris. And from, I want to say, for our reader or for our listeners, if there was going to be one way or one word, let's say, that you would use to summarize your entire conversation with me here this morning, what would you choose?
I'm going to use your word, holistic.
I love it. I gave that one away. Darn it.
Thank you.
I think that's a good way to put it, Chris.
I agree, Christoph. Well put.
Well, from one Chris to another, I want to say thank you, Chris, for joining us on the podcast today. It was an absolute pleasure having you, and hope we can get you to come back sometime in the near future.
Thanks very much, Christoph. Appreciate it.
Thanks for joining us on this week's episode of the Authority Podcast, Plumbing and Mechanical. Love this episode of the podcast? Head over to iTunes to subscribe, rate, and leave a review. Please follow us on Twitter @AuthorityPM, on Instagram @TheAuthorityPodcast, or email us at iatmo@iatmo.org. Join us next time for another episode of the Authority Podcast, Plumbing and Mechanical. In the meantime, let's work together to make our buildings more resilient and shape us for the better.